Hello, Miss Ebert. I am Kevin Sherberlin. This is my project for the second semester. So first off, we're going to start off with part 1. And for part 1, I filled in everything that I knew and made a nice rectangular shape. And I plugged in the 7 inches for the depth, the 9 inches for the length, and the 18 inches for the width. And then I plugged that back into the Pythagorean theorem because we wanted to see the diagonal corner to corner, and I got that 9 squared plus 18 squared is equal to c squared. Now we're going to add those two together. 81 plus 324 is 405, and then we're going to set that equal to c squared, and we're going to isolate it, the c, by square rooting both sides. And we got that the diagonal piece had to be approximately 20.1 inches. And then now for number 2, we know I plugged in what I knew, that first I wanted to see the maximum length that the hypotenuse could be, and I plugged in 40 squared plus 15 squared is equal to c squared. 1600 plus 225 is c squared, and then I square rooted both sides, and I got that at its maximum it could be 42.7, but we only have 28 feet because 2 of the 30 we had to use for the stake, as you can see in the little square next to the right triangle at number 2. So I plugged in 15 for the bottom because that is a constant and we can't change that, and then the 28 for the hypotenuse, and I got plugged that back into the Pythagorean theorem to see how long the leg was, because we don't know how long it is. So I got a squared plus 15 squared is equal to 28 squared. A squared plus 225 is equal to 784. Square root both sides, square root both sides. A is equal to approximately 23.6 feet. And then for part B, we had to just find out, is it 2/3 of the whole top length? So I did 40 over 1 times 2/3, and I got a 26 and 2/3, and then I plugged in if 23.6 was greater than 26 and 2/3, and no, it is not, so local regulations have not been matched. For the third one, how to deal with compound interest, I plugged in the 882 for the annual growth, the 800 for the principal, and then parentheses 1 plus rate, and parentheses, put the 2 years in for the t for the time, and I executed everything. So I got 800. I executed the squared, so I got 882 is equal to 800 times the quantity of r squared plus 2r plus 1. Then I distributed the 800. I got 800 r squared plus 1600 r plus 800, and then I subtracted the 882 to get my 0. 0 is equal to 800 r squared plus 1600 r minus 82, and then I plugged everything into the quadratic formula to solve for that pesky r squared, and I plugged in everything, and I got x is equal to 1 over 20. That means she is making 0.05 for her rate per year. Looking forward to the next page now for number 4. I drew out the rectangle, and I found that the area is equal to 1400 inches squared, and I know that area is equal to length times width, and our width is length minus 22. So I plugged in using substitution property for W. I found that area is equal to the length times parentheses, the length minus 22 end parentheses. I distributed the length out to the parentheses, and I got the area is equal to the length squared minus 22 lengths. And I plugged in the 1400, so to get the length 1400 is equal to the length squared minus 22 length. And then I subtracted the 1400 to get our 0, and I got 0 is equal to our length squared minus 22 length minus 1400. And then I plugged everything into the quadratic formula. As you can see on the left, I put it in the original equation for the quadratic formula, and I execute everything out and got the length was 50 inches, and since the width is the length minus 22, I got the width is 28 inches because 50 minus 22 is 28, and I checked to see is 50 times 28 equal to 1400, and 1400 is indeed equal to 1400. Now for number 5, I got that the volume is equal to 128 inches cubed, the height is 2 inches, and the width is equal to the length, because squares have the same length and width. So plugging everything in, I got 128 is equal to 2L squared, and I divide everything by the 2 to get 64 is equal to the length squared, and I got the length is equal to 8 inches, which means that width is equal to 8 inches, and since I already know that the height is 2 inches, I got the dimensions are 8 inches by 8 inches by 2 inches, as you can see that I wrote it out on the right. And now for number 6, volume is equal to length times width times height, and I plugged in the length, x plus 2 times 2x plus 1 times x plus 5, and then I had to subtract some because of the other rectangular prism was taking out some of our original one, and it wasn't perfect, so I set all of that subtracted by 3x times x plus 5, and then I set that equal to the volume. I distributed everything to get x, to put everything back in standard form, to get 2x squared plus 5x plus 2 times x plus 5 is minus 3x squared plus 15. Just some more math. And then I subtracted the values to get 2x cubed plus 12x squared plus 12x minus 198 is equal to 0. And I took out a greatest common factor of 2, and then I divide everything by 2, and because 0 divided by 2 is 0, that kept the same. And since we can't use negative numbers, there is really only one answer, so x minus 3 equals 0, x has to equal 3. So, and if we plug everything back in, so 3 plus 2 times 2 times 3 plus 1 times 3 plus 5 minus 3 times 3 times 3 plus 5, and we got that the volume is equal to 208. Now, flipping over the page, for number 7, we are trying to see the distance that they are, and since we know that Jack is going north and Rob is going east, then we can and we know that Jack is going twice the speed. We also know that he's going twice the distance. And because of that, we can solve for 225 is equal to x squared plus 4x squared, and 225 is equal to 5x squared. Divide each side by 5 to isolate the x squared. And we got 45 is equal to the square root of x squared, and square root both sides, of course. And we got Rob went approximately, well, he went 6.7082039 miles, or approximately 6.7. And going on now to number 8, we know that the students are basically going into a right triangle, and going across the field is 20 feet diagonally. So we know that would be 400 if we do our c squared. And we were given for our a squared and our b squared, x squared plus x plus 8 parentheses. Those are in parentheses squared. And we do 400 is equal to x squared plus 16x plus 64. Combine like terms and subtract the 400 from both sides. And we get 0 is equal to 2x squared plus 16x minus 336. Get the GCF and divide it out. And we get finally x squared plus 8 is minus 168 is equal to 0. Plug it into the quadratic formula, and we get an exact answer of 7.380831596, or approximately 7, give or take rounded to the nearest whole number. And if we plug that into x plus 8 plus x, because we need to know the side things to add them up so we can get the total distance that they went, we get 7 plus 8 plus 7 is equal to 22 feet. And seeing as they went 20 feet, and 22 minus 20 is equal to 2, so they saved 2 feet by cutting the lawn. Now finally transitioning to page 4, we were given the zeros, and we had to find the polynomial. So we got -8, -2, and 1. And since we know that has 3 terms, that means it must be a quad or 4 terms, or to the 4th power. And so I plugged in all that I know, and I also know that there must have been a multiplicity. So I plugged in x minus 1 to find if the x minus 1 was the multiplicity by using guess and check method, and I got x to the 3rd minus 2x squared plus x plus 2x squared minus 4x plus 2. I'm going to combine those group by grouping. I got x plus 8 times x to the 3rd minus 3x plus 2. And I got x to the 4th minus 3x squared plus 2x plus 8x cubed minus 24x plus 16. And I got x to the 4th plus 8x cubed minus 3x squared minus 22x plus 16. And I went to my calculator to graph it to see if it satisfies our condition that y has to be greater than 0 when x is greater than 0, and found that when x is greater than 0, y is greater than 0. So all of my conditions were met. And now going on to number 10, we were given that it was a 4th degree polynomial with the real roots of 2 and -2 and a complex root of I. And so basically what I did was I thought to myself, well, how do you get to these answers? So I basically worked backwards and got square root of 4 and the square root of -1. So I got x squared is equal to 4 and x squared is equal to -1. Put those back into what I will call factored form, and then split up the x plus 2 and the x minus 2, and then do that times the x squared plus 1, and I'm going to plug it back in, and I'm going to use a subset n to see if there is a constant, and I plugged in the negative 150 for the g of x, so I got negative 150 is equal to a, and I plugged in 3 for all the x's, so a times quantity of 3 plus 2, the quantity of 3 minus 2, and the quantity of 9 plus 1, and I got negative 150 is equal to a times 5 times 1 times 10, and I got negative 150 is equal to 50a, and divide each side by 50, and I got a is equal to negative 3, and I went ahead and went to put that negative 3 in so I can get my polynomial. And so I went back to standard form by multiplying everything out, and I got negative 3x to the fourth plus 9x squared plus 12, and then I went to go back to check if the answer was correct and satisfies that when x is equal to 3, y is equal to negative 150, and so I plugged everything back in. Negative 243 plus 81 plus 12 is equal to negative 150, and negative 150 gives me a true statement, meaning my solution is correct.